Hey everyone, welcome back to the channel. In today's video, we are going to solve an interesting and slightly tricky problem from LeetCode 3017. Count the numbers of houses at a certain distance to. This problem looks simple at first, but once you dive in, you'll realize it involves graph logic, distance calculations, and optimization techniques. To avoid brute force solutions, we are given a special structure of houses and connected by roads. And our task is to efficiently calculate how many house pairs exist at each possible distance. In this video, I will walk you through understand the problem step by step, breaking down the key observations, designing an optimized approach, and finally implementing a clean and efficient solution. Whether you are preparing for coding interviews or improving your problem solving skills, this problem is a great example of thinking beyond the obvious. So grab your coffee, open your editor, and let's get started. So guys, here you can see it, one more video came on the LeetCode Camp channel. So in today's video, we are telling you about, we are solving out some little bit tricky question by the name of 3017 by the name of count the numbers of houses at a certain distance to. So let's try to solve today's question in Python 3 by the way. And this question included some of the 4 hints, but we don't see any hint. We will solve it with our own brain. Okay, so let's try to see let's view out the question. Okay. Now it has given me a 3 positive integers in today's question by the name of n, x and y. In a city, there exists a house numbered 1 to n which is connected by n streets. There is one street which is connecting the house numbered I with a house numbered I plus 1 for all 1 less than equals to I less than equals to n minus 1. Okay, and an additional street connects the house numbered x with the house numbered y for each k such that 1 less than equals to k less than equals to n. You need to find the number of pair of houses house comma house such that the minimum number of streets that need to be traveled to the reach house from house is k. Okay, we want to return a one index array result of length n where result k represents the total number of pairs of houses such that the minimum streets required to reach one house from other is k. Note that the x and y can be equal. Okay, please note that. So if you see this diagram, it is going like this. Okay, if you see like 1 to 2 and 2 to 3 and then 3 is directly going to the 1. Okay, it is looking like this. Okay, if you see here you get one integer n by the name here you get one integer in which by the name of n in which is written down 3, and here you get one more integer by the name of x in which is written down 1, and here you get one more integer by the name of y in which he written down 3, and the output is coming 600. Let me explain you. Let's look at each pair of houses. First, for the pair 1 2, we can go from house 1 to house 2 directly. Number 2, for the pair 2 to 1, we can go from house 2 to house 1 directly. Okay, and then number 3, for the pair 1 to 3, we can go from house 1 to house 3 directly. And in number 5, we for the pair 3 to 1, we can go from house 3 to house 1 directly. For the pair 2 to 3, we can go from house 2 to house 3 directly. In last pair, for the pair 3 to 2, we can go from house 3 to house 2 directly. So that's why the output incoming 600. Now if you see the second diagram here, this diagram is working like this. If I show you 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then again it is going on to the 4 and 4 is going on to the 2. So it is looking like this. Okay, if you see the input here, you get one integer n by the name of 5, integer by the name of n in which he wrote in the output 5, and one more integer by the name of x in which the output is 2, and one more integer by the name of y in which the output is 4, and in which the output is 4, and the output is coming 10 8 2 0 0. Okay, why? Because for each distance, like the pairs are like for k equals to 1, the pairs are 1 2 2 1 2 3 3 2 2 4 4 2 3 4 4 3 and 4 5 and 5 4. And in the number 2, for k2 the pairs are 1 3 3 1 1 4 4 1 2 5 5 2 3 5 and 5 3. And the for k3 the pairs are 1 5 and 5 1. And for k4 and k5 there are no pairs. Okay, so that's why the output has been coming like this: 10 8 2 0 0. If you weigh out the third example, the third example is looking like this, like 1 to 2, 2 to 3, 3 to 4, and then when it has been done, then it is going like 1 to 1. Okay, like this. If you see here, you can see it. Here you get one integer by the name of n, in which the output is 4, and here you get one more integer by the name of x, in which he wrote it on 1, and one more integer by the name of y, in which he wrote it on 1. And the output has been coming 6420. Why? For each distance the k pairs are, like for k1 the pairs are 1 2 2 1 2 3 3 2 3 4 and 4 3. And for k2 the pairs are 1 3 3 1 2 4 and 4 2. For k3 the pairs are 1 4 4 1. And for k4 there are no pairs. Okay, so that's why that type of operand coming. And it has been given you two constraints are also included, but if you want to see it, so see it. Okay, so let's come on our Google Chrome, let's come on it here, and this is the hard one question which we are solving. Okay, so that's why it is a little bit tricky. And in this question there are 4 hints are included because this hard question, so that's why. But we don't see any hint. Okay, but we only see the topics. There are 3 topics are included: graph, prefix sum, and weekly contest 381. And only 23% people solve this question. Okay, so if now you can think how much tricky and hard question it is. So first of all, we define class of a solution. Def count of pairs, that comma and is our int, x is also a int, and y is also a int. Y is also a int, and then we define equals minor greater than less int. Now we define if x is greater than y, and then we define x comma y, y comma x, y comma x, def inside cycle, we define length cycle. Frequencies equals to 0 multiplied by n. For I in range, here we define length cycle minus greater than less than 2 and then semicolon. Define frequencies again, I plus equals to 2 multiplied by length cycle. Enter back if length, then C, and then add 1 0 0, sorry, equals to 0, enter. Frequencies, and then this length, then define length cycle minus 1 2 and plus equals to length cycle. Enter back, return frequencies, enter. Now we have written these codes. Now we want to write more codes inside lr length frequency 0 multiplied by n multiplied by 2 for I in range length minus 1. Frequencies plus equals to length minus 1 minus I multiply by 2 back. We define return frequencies and then call and then enter back def lr to cycle length cycle frequencies equals to 0 multiply by n multiply by 2 for I in range length segment frequencies I plus 1 if length cycle is then module sign then 2 equals to 0 frequencies I plus 10 length cycle 2 then minus equals to 4 enter frequencies I plus and then length cycle 2 okay and then 2 here we wrote it down okay by the way basically I do not open my numlock so that's why it is not working plus equals to 2 enter frequencies I plus 1 plus length cycle equals to 2 and then minus equals to 2 and then when we wrote it down these codes so now we come up so let me zoom it okay by mistake oh sorry let's reset it so now it is perfect now when I run this code so we have read over all the code so when I run this code so let's see the running code so when I run this code so now the running code has been accepted let's submit this code so when I submit this code now the submission code is also be accepted and I beat total 82% people so I hope you enjoyed today's video if you enjoyed so don't forget to like share and subscribe for more of these new tutorials and please press all bell icons so if I upload any new video on my channel so the link will become onto your inbox okay so now let's meet in your next video amazing video like this so for today goodbye.